By the end of this video, I'll expect you to understand how to seek an independent entity in a conversation with users, the kinds of problems it solves, and also why we would want to avoid arbitrary IDs when possible. There's several circles and lots of arrows here, but this last step is fairly straightforward. All we're doing is checking to see if we should evolve the entity we're looking at into what we call an independent entity. Either yes, we will do that, or no, we will confirm and keep the entity that we already had. First, recall that a dependent entity has one identifying link and at least one identifying attribute. Student here is an example of a dependent entity. It depends on school, which is called an independent entity because all of its identifying descriptors are attributes. In this case, only one, the school ID. School has no identifying links. School does not depend on any other entity to identify its instances. Let's anchor our understanding. According to this model, a student ID like 42 can repeat across schools, but it must be unique within a school. This might be what the users are looking for, or it might not. Maybe they would prefer that a student ID was unique throughout the whole system and not be allowed to repeat across schools. This would probably require longer IDs to manage a larger student population on one ID numbering system, but there are operational advantages to either. In this case, we could change student to be an independent entity. Removing the bar from the link to school would completely change the way that student ID is used. It would stand alone as an entire identifier. This would allow something new to happen. If student becomes an independent entity, it can exist on its own without a school. So, we could create a student that is outside of any school. This might have meaning to the users. They might want this to be allowed, or they might not want it. It's our job to ask. Investigating this possibility is the main reason to seek an independent entity from a dependent one. So let's return to where we started, with student as a dependent entity, and ask the users a question. Can a student exist without a school? Suppose they say yes. Now the student ID comes into question because we were depending on school to distinguish students with the same ID. So we would need to follow up with a second question. Suppose you have two students with the same student ID who do not have schools. How do we distinguish them from each other? At this point, the users might have difficulty answering, or they might say that students cannot have the same student ID. If they have difficulty, it might mean that the student ID system that they're under needs an overhaul, which might be an operational nightmare for the school administrators to consider. Or it might be that each student needs an arbitrary ID added that is a system-wide unique ID. Either way, if we decide these students can exist outside of a school, then this would mean that we will need to convert to an independent entity. In general, seeking independent entity means considering omitting identifying links from the identifier, typically because they might be null, like when student had no school, and only using identifying attributes. Part of this step might mean redefining, renaming, or even completely replacing the existing identifying attribute like student ID. This example covered a dependent entity. We can also extend this concept into intersection entities. Here's an example. This is John Carlos's favorite data model fragment, creature achievement skill. We will be referring to this many times in the course. We have some kind of fictional world in which many different creatures can achieve many different skills. Skills like engaging hostile aliens in a jet fighter. Creature and skill here are independent entities because all of their bars are inside the box. They have 0 bars on links. Achievement is an intersection entity. It has 2 bars with links. It's certainly not an independent entity. We also don't call it a dependent entity, even though its identifier does depend on other entities. We reserve the term dependent entity specifically for cases like student and school, where there's only 1 bar with a link. As modelers, we call this an intersection entity because of its shape. It has 2 bars with links. Anytime we have a dependent or an intersection entity, there's a chance that an independent entity might be better suited to the problem. But we don't want to make that decision for the users. We want it to come from them. We can get them to make that decision by asking the right questions. These terms, independent, dependent, intersection, are LDS modeling vocabulary that we modelers can use among ourselves to communicate quickly. But to users, this is jargon, and we don't want to use it when discussing with them. We can't just ask the users, should achievement be an independent entity? They won't know what that means, and we don't need them to. Let's suppose we've already gone through the conversation with users, checking the identifier, and we've decided that creature plus skill is neither over nor under identifying. That's great, but it might not be good enough. We still might need an independent entity here. That means considering a replacement identifier that includes no links and only attributes, either existing ones or new ones. Here's an example of the 3 statements we use to explain an identifier that has 2 descriptors, as achievement does here. In the last 2 videos on under-identification and over-identification, we focused on statements 2 and 3, which explain what instances are allowed. Statement 2 is restrictive and calls attention to possible under-identification. Statement 3 is permissive and calls attention to possible over-identification. Getting back to statement 1, we remind the users that according to this LDS, each achievement must have a creature and must have a skill, because that's how we distinguish one from another. It's possible that we cannot remember the creature of achievement or the skill of achievement, and in that case, this identifier doesn't work and we need a different one. So this statement calls attention to the possible need for an independent entity with its own identifier. To the users, we can restate the must remember statement and then drill into it in 2 steps. First, ask if it's possible that we cannot remember the things that we said we must remember. Then, if they say yes, follow up by asking how the users can distinguish one instance from another. So, is there such a thing as an achievement with a creature we do not know, or an achievement with a skill we do not know? If the answer was yes to either or both of them, suppose you have 2 achievements that do not have a creature, or suppose you have 2 achievements that do not have a skill. How do you distinguish those achievements from each other? Just like the students in school's example, this can be a difficult question for the users to answer. And if they don't have an answer, we can step in and offer the possibility of adding an arbitrary identifier to achievement. This is something new we're adding without explicit direction from the users, so we need to explain what it is. We can say, it appears we will need to use an arbitrary identifier, a meaningless number or a piece of text, to identify each achievement. If we carefully assign an identifier value to each achievement, we can use that value to forevermore refer to that achievement. If the users agree, then we can make the change as we proposed, and we've converted to an independent entity. That's the end of this step in the process. Before we move on to the review questions, some of you might be wondering, all this work just to find out we need a unique ID. I could have been at a barbecue. Can't we just put an arbitrary unique ID on every entity? In fact, we could skip putting identifier bars on the LDS completely. Wouldn't that save us time? Some examples of arbitrary unique IDs might be an integer or some piece of text like this hexadecimal string. These are codes that, of course, we would want the system to automatically generate for us so that we don't have to manually think them up ourselves. In terms of distinguishing one instance from another, yes, these kinds of IDs always work, in that you could include one on any entity and you would have a system for distinguishing one instance from another. But just because you can do that doesn't mean you should. Arbitrary IDs have drawbacks, especially in the modeling process. They're uninformative, and they do not help communicate what the thing is. If you look at these codes above, you can't tell if they're identifying a person, a physical object, a process, or what. They're completely arbitrary. For users, unique IDs do not relate to anything tangible in their domain, and unique IDs are likely to be ignored in the conversation instead of driving key decisions. For modelers, unique IDs offer no insight into the user's domain, and they offer no guidance on how we should evolve the model. The goal of this user-driven approach to data modeling is to determine what data should be stored, and not how it should be stored. What, not how, will be a recurring theme in this course. To do this, we need to communicate precisely, and the process around identifiers offers an excellent way to do that. In terms of database schema design and code implementation, Yes, of course, when it comes time to build your database, you can decide to put automatically generated unique IDs on all of your tables. Though, as an aside, we're actually not going to recommend automatically choosing unique IDs in your databases either, because we think the final implementation should be as similar to the data model as possible. But we understand that if you're using Ruby on Rails or similar frameworks, you might have technical reasons why you're forced to use unique IDs everywhere. For now, this is all beside the point of the exercise. Implementation is not what we're talking about here. Discovering what needs to be stored is a joint process between modelers and users. It requires excellent communication. And if we can stay on the same page about what each instance means, we've cleared a roadblock to building great software. The process we showed in this video gives us a path to adding arbitrary IDs when all other options are exhausted. We've covered an example with a dependent entity and also an example with an intersection entity. Here's another example with a three-way intersection entity, so check your understanding.